Hi statistics student, this video is for chapter 8.1 part 2. In part 1 videos, we are doing confidence interval of this example. For what is it about? It's for this mean score of a standardized test using a sample mean of 137.3. We know that 137.3 is not exactly the real mean of the standardized test population mean, so we think that it should be in a range, or actually the real mean is a number, it's not in a range. The real mean is a number, but it could be any of these number, okay, because we know that the error is 21.76, so it could be as low as 115 and as high. So let's look at the second part. At a confidence of 98%, what is the significant level? Significant level is just the opposite of confidence. So 2% is significant, right? So in decimal place, we write as 0.02. So that's what it is. Alpha is 0.02. Alpha is significant level. What is the critical value? Critical value is the cutoff in the z-score. That means how many tick mark are we that would get into the cutoff point, where on this side is confidence, on this on the left side is confidence, on the right side is significant, that is rare. So if the two tail, the middle is 98%, then each tail would be 1%, right? Because 2% divided by 2 is 1%. So we'll have 1% as a right tail, and this is the critical value. We write it as z.01. So we know how to do it, z.01, right? I think I have this question in a classwork 6.1. So, but we will just review it. So if we are to do that, we use inverse normal distribution calculator. Write 0.01 on the right side, above is 2.326. So that is, the critical value is 2.326. That means is 2 tick mark from the mean. Each tick mark is sigma over square root n. So C, a previous study showed that the mean score was 144.2. Is the population mean score below 144.2? Oh. Our sample mean score is below 144.2. But what is our population mean? So when they ask this, they are not asking for sample mean, they are asking for population mean. So usually this is asking for that. So let's look at our estimation of what the real mean is. So the easiest way is to draw the number line. That our real mean is from 115. You actually forget about your sample mean. 115.54 to 157.06. Any of these data, it could be mu. We don't know which one is, but there's just one number. It could be anyone. Can all of these numbers below 144? Some of them are, like these are, but it cannot be, because if it could be 152, it could be 157. These are not below 144, so we would say no. Okay, no, because 144 is in the interval. It is not, the whole interval is not. So when you make conclusion, it has to be the whole interval. So you would say that some numbers, some possible values of mean, mu is not below, right? And then some other, explanation would be, well, it cannot be because 144.2 is actually in the interval. Okay, D, explain what will happen to the margin of error if sample size increase. So usually we say if you use more samples, usually it would reflect more accurate, right? More accurate estimation. So the same, you can use the same argument that larger samples are more accurate, but what is the mathematical reason that this would be? This is like common sense. So you would have to use the formula to say, to calculate E is Z over 2 the critical value times sigma over square root n, right? Use this. And so this is the standard error. So if n increase, you're dividing a bigger number. It's like this is fixed. 14, for example. You divide by 10 versus divide by 100. There's a big difference. So if you divide by a bigger square root of n, your e, of course, is increased, right? So because they are inversely proportional, they're not directly proportional. So you would say when n increase, you're dividing by a smaller number, so e would decrease. Like if you divide by 2 versus divide by 3, you will have smaller number. Explain what would happen to the margin of error if the confidence interval is 99%. So draw a picture again. Draw a picture. In the past, it was 98%, so your z here, right, you use this z, and then, so this is 98%. If you change yourself to 99%, where is the critical number? So the critical number is like 2.3 something, right? Now, if you do that, then your two-tail will be 0.5%, right? Alpha is 1%, so this is used to be 1%. Now it is 0.5%, 0.5%. So of course, this would be pushed to the right more. It would be more than 2.3. It's a larger z alpha over 2, right? If you have larger z over 2, e is multiplied by z alpha over 2 times sigma over square root n. If this doesn't change, but this is increased, so e will increase because it's directly proportional to it. When z increase, you would have the e increase. Both increase together. You have a larger error. So the more confident you are, your range will be larger so that you would include the real mean. Next example for 8.1 is showing if you do not have summary data. You did collect a sample, but you only have the sample. You haven't entered into statistics and find x bar and n. So you actually collect this yourself. So you actually have the raw data. The last one maybe is published by someone, right? That x bar is 137. This is what you collect yourself, and you want to use this sample to find a 95% confidence interval of the mean level of cell phone. So this is cell phone, what is called radio frequency energy level. That means, if you use a headset, or I think they say handset. Handset means cell phone. I don't know. Yeah, cell phone. So they have some, electric magnetic field that will affect your body. So this is what is being absorbed by your body and measuring. And it's supposed not to be big. So these are like 30 cell phones data. And because it's around 30, so we know that it is x bar is normally distributed. We can do a confidence interval only if the central limit theorem apply. So again, we would use the statistics. I enter the data. Did I enter the data? No. I enter the data into an Excel spreadsheet for easy of copying. Right, 30 data. Right. So I copy it over to statistics here. Copy into column 1 by Control V. And I want to build a confidence interval for mean. One sample. So this is a sample statistic. I don't need it. I use data. So you click this tab, it would say data. It is 95%. My number is in 1. But I know population standard deviation. They give it to us. So what is it? They say the standard deviation, population standard deviation is 0.337. If you have it, you must enter it. Because if not, you would have a different answer. Okay, so this is the answer. E is 0.121 if we want 3 decimal place. And then the mean is 0.903 and 1.144 for 3 decimal places. So go to the next page. So I say, yeah, use the data tab. And then I have this 0.1. No, not this one. Yeah. I don't know where this comes from. So it should be another one. I think I should overlay it. Oh, where is it? It should be this one. 1 2, yeah, 1 2 1. So let me just change it. When I publish the notes, it should be the updated one. Okay, 0.121. This is 0.903. So these are radiation level, so they should be low. And this is 1.144. Right? Using data, use the data tab. Use the confidence interval in the form of interval notation and plus and minus notation. Interval notation is easy. It's the lower limit, comma, upper limit. So 0.903, comma, 1.144. So that's called the interval notation. The plus and minus notation will be x bar plus and minus e, right? So I don't have x bar. So what I'll do is I'll go back to my data and then actually find x bar. Some statistics output will provide x bar here, but this one doesn't. So just do a x bar here. X bar is mean 1.024. 1.024. So I would say the plus and minus notation would be x bar plus and minus e, right? So x bar 1.024 plus and minus e is 0.122. 0.121. 3 decimal places. Can we conclude that the mean SAR level is below the allowable 1.6? So let's draw the number line. 0.903 to 1.144. 1.6 is way over here, right? 1.6. All of these mu values, so they are possible one, we don't know which one, is below 1.6, so we say yes. Find the critical value of Z alpha over 2. So we are doing 95%, right? So we will draw the picture. It's easier you will draw the picture. So middle is 95%. The 2 side is 5% divided by 2 is 2.5%, right? 2.5 in decimal is 0.025. Okay, 0.025. So I think we did those before. So we just do it again. Or actually 0.025. I think it's the default 1.96. Yeah, 1.96. So you say the critical value C 0.025 is 1.96. If we want to decrease the margin of error, what can be done? I don't like this margin of error of, what is it, 0.121. I want it to be smaller, like maybe 0.1 or 0.0 something. So what should I do? So let's write the formula. Margin of error is C alpha over 2 times sigma over square root n. So this cannot be changed. So we can make this smaller, or we can make this bigger. So the one thing that you can do is increase n, increase sample size. The second thing you can do is make this, push this towards the end, right? Because this is 1.96. If you use a bigger confidence level, then your significant area will be smaller. So the Z alpha over 2 will be pushed to the right side. It will be a bigger Z alpha over 2. So you would have a, oh no, you want to decrease it, right? You want to decrease, yeah, you want to decrease, then you should, it's not increase. You should be decreasing this, right? So you should use a, because otherwise you will have a bigger margin of error. So I should decrease this C level. So this would be like, the critical value would be like here, going to smaller number. Smaller number means smaller E. Okay, so decrease C level. So instead of 95, you can say 90%. Yeah. So we'll do a part in the next video. We'll talk about sample size.